Hello, I'm Joe Chu, and welcome to Live Indexing. In other videos, we have talked about the write path and the read path for DSC search, specifically the default process, which is called near real-time indexing. However, for a while now, DSC has also had an alternate process for indexing, which is what we call live indexing or real-time indexing. Live indexing is a feature that is found only in DataStax Enterprise and has been around since version 4.7. That's at least 2 major releases and several minor releases, so it's been around for quite a while. The main idea behind live indexing is to be able to search documents while changes are still in the RAM buffer, rather than having to wait for a commit and a new index segment created. This should allow faster indexing throughput because it would not be necessary to soft commit frequently if the index is already readable, and therefore it reduces the flushes and merges that may take place in the background. Live indexing should also help lower read latency, since often search will be reading through the index directly in memory. Let's first review what happens using near real-time indexing. When documents are updated, they are added to the in-memory RAM buffer. A soft commit may be triggered from several different events, such as auto soft commit max time, and the updated documents will be flushed to disk as a new index segment. As the segments increase, a merge can be triggered, which will combine multiple segments together into one larger segment. Only the documents written in the index segments are searchable when retrieving results for a search query. Here we start off the same way, with document updates being indexed in the RAM buffer. With live indexing, the changes to the index are readable while they are still in the RAM buffer. Additional document updates will still be added to the RAM buffer and can be read from there. However, there is still a period of time where it may not be visible for new searches, but it can be much shorter compared to near real-time indexing. There are no soft commits with live indexing since it is not needed for visibility. However, a hard commit can still be done instead and occurs when the corresponding Cassandra mem table flushes, or if the RAM buffer threshold is reached. Again, changes to the index will be added to the RAM buffer, and a search will read from both the RAM buffer and the index segments to retrieve results. One other thing that is supported with live indexing is the use of off-heap memory for the RAM buffer, which can be enabled in the search index config. By being able to use memory that is not limited to the allocated heap, this should reduce the need for garbage collection and should also help improve performance. There are several different ways to turn on live indexing, depending on what tools you're comfortable with using. The simplest would be an index management command in CQL. If you want to create a new search index, you can do so with live indexing enabled by adding the config option real-time set to true. Otherwise, an existing search index can have its configuration altered by using the configuration shortcut real-time and setting that to true. DSC tool has been around the longest, and users may be more comfortable with using this command line tool instead. If you would like to enable live indexing on a new search index, you'll need to create a YAML file that contains the setting RT and have that set to true. Afterwards, the YAML file can be included as part of the core options when creating a new search index with the DSC tool command create core. Note that you must also use the generate resources option to automatically build the solarconfig.xml. Otherwise, if you're passing along your own solarconfig XML file, DSC tool will not be able to edit your file to include the RT setting. Speaking of the solarconfig.xml, it is possible to add the setting to enable live indexing directly into the XML file. Under the index config element, add the element RT with the value true. Afterwards, you can reload the search index to have the setting take effect. Live indexing has the potential to significantly increase the read and write performance of DSC search, but there are some recommendations that will help ensure that live indexing performs optimally. We'll be going over these one by one, but the first one that I want to mention is actually the last bullet point here, which is to limit the use of live indexing to only one search index in the cluster. Live indexing itself can be resource intensive, and enabling it for more than one search index may actually be detrimental for performance. Another recommendation would be to lower the auto soft commit / max time value. The suggested value is 1000 milliseconds, which is actually the maximum value when live indexing is turned on and can be set lower. In the case for live indexing, this setting is not when a soft commit is performed, since we no longer need soft commits, but it does control when the view of the index in the RAM buffer is refreshed. An example of changing the setting would be to use the CQL command, like at the bottom here, to change the auto commit time. Even with the maximum value of 1000 milliseconds, this makes reading new changes to the index much faster than with near real-time indexing, which starts off at 10,000 milliseconds or 10 seconds before your search results start to see new changes. We previously mentioned that having the index written to and read off heap removes limitations to the heap memory usage and can improve garbage collection times and prevent out-of-memory errors. You can turn on off-heap allocation by executing the CQL command below, which modifies the search index configuration. The final recommendation is to make sure you increase the size of the JVM heap as much as possible. With DSC search, you usually will want to have at least 14 gigabytes of heap memory allocated for the JVM, if not more. A bigger heap will allow for a larger RAM buffer size, and having index updates in the RAM buffer will decrease the number of background operations, such as flushes and merges, that occurs in the background. The heap size can be changed in the cassandra-env.shell file by uncommenting the settings max heap size and heap new size, and then changing max heap size to your desired value. If using the G1GC garbage collector, the value of the heap new size is not important and will actually be tuned automatically over time based on heap usage. If you're upgrading from an earlier version of DSC, keep in mind that the setting RAM buffer size MB is no longer used, as DSC will now adjust the size of the RAM buffer automatically. If you use a Solar config from earlier versions with this setting, you may see this warning: Solar config RAM buffer size MB is not supported. There's no need to panic, as this setting will just be ignored, but you may want to remove that setting from your Solar config file when you're upgrading. It's been a while since the last exercise, but we have some hands-on for you to do here. Open the notebook for the exercise live indexing and get started.